Hello and welcome back. This is Saxon Math, Course 1, Lesson 20, Greatest Common Factor. We're going to look at the greatest common factor. It's a little bit different than multiples, all right? Let me explain this. Multiples equal something like 2, 4, 6, 8, 10, 12, 14, and on and on and on, counting by multiples of 2. Another example of multiples might be by, I don't know, let's just do 10, for example. 10, 20, 30, 40, 50, and on and on. Those are multiples of 10. Those are not factors. Factors are a little bit different. They sometimes get confused. Factors will be numbers such as, let me just explain it here. A factor would be something like, if you have the factors of 12, those are all the numbers that can be divisible, that 12 can be divided by without having a remainder. These are the factors of 12. So those are the factors of 12 in this case. These are multiples. This is the multiples of 10. This is multiples of 2 in this case. So factors are what we're looking at today. Those don't go on to infinity. There's finite. There's not an infinite amount of factors. Multiples, they're infinite. They never end. That's what this dot 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 means. It's going to go on forever to infinity and beyond. 2 at 2 each. If we were to add 2 and we went on to infinity, this one was by multiples of 10 on to infinity, never stopping. Factors have a definite end, beginning and an end. They have 1 as the beginning. They have the number, whatever the number is. It could be any number in infinity, but it's always going to start with 1 and whatever that number is, and then everything in between is going to be a factor that is something that's divisible without a remainder. So 12 divided by 6, what's that? Well, it's 2. What's 12 divided by 4? It's 3. What's 12 divided by 3? It's 4. What's 12 divided by 2? It's 6. What's 12 divided by 1? It's 12. What's 12 divided by 12? It's 1. All of those are factors because there's no remainder. 5 is not a factor of 12. So because if we took 12 divided by 5, you'd end up with 2, would get us as close as we can. That'd be 10. There'd be 2 left over. It's a remainder. So 5 is not a factor of 12. It has a remainder, or would end up being a decimal or something of that nature. So let's look at greatest common factor. So the thing here, in this lesson, we're looking for the greatest, which means the largest or the biggest. Greatest means the largest. Common means the same. And factor is what I was just explaining here, the numbers that are divisible without a remainder. Not multiples. We're not looking at multiples today. That's not what this is, this particular lesson. So we're only looking at factors, and we're looking at the greatest common factor. So it's the largest that's the same when we're looking at 2 sets. So like this is the factors of 12. But let's look at an example. So first of all, you would list in order the factors of the smallest number. So if you have 2 numbers we're talking about here, and then starting with the greatest factor, cross off factors that are not factors of the other numbers. So here's an example. Circle the greatest factor that is a factor of all the numbers. This is the greatest common factor. So if you have the factors of 6, 9, and 15. So the factors of 6 are 1, 2, 3, and 6. Those are the numbers that are divisible by 6 without a remainder. The factors of 9 would be, and let me write this in another way. So 6 is not a factor of 15 and 9. Let's forget about this mess for a second, because this is, I don't know why the book does this. The book is making a mess of that in my mind. Maybe you can figure it out. So I'll just leave that available to you. But that's a mess, all right, in my mind. So I'm going to do it a different way. math, there's a million different ways to do something, and that way that the book is doing is not the way I like it. You can find another way. You have maybe another route to get to the same answers. I'm just going to go with the factors of 6 I know are 1, 2, 3, and 6. The factors of 9, are 1 and 9 to begin with. And then I know that it's going to be 3 because 2 doesn't go into 9. 4 doesn't, 5, 6, 7, 8, none of those do. So it's actually just 1, 3, and 9. And the factors of 15 would be 1 in itself again. So 1 and 15. And then it would be not 2. 15 divided by 2 is 7.5. So that's not, or it's not 2, but 3 works. 3 times 5. And then 4 would not work. So these are the factors of 15. 1, 3, 5, and 15. So the greatest common one, they all have these in common. So this doesn't really work. Even though that's common, that's common, that's common. You can see that 3 is also common. They all have 3 as a factor. And then 6 is not here, it's not here or here. So it's only in this one. So 3 in this case is the greatest common factor if you look at it, because even though 1 is sort of common, it's pretty much not considered a common factor, even though it's in every single one of those on to infinity, 1 in themselves. But 3 is the greatest common one in this case. So if it happened to be 1, there isn't really a greatest common factor if there isn't a common factor, even though if it was 1. But let's look at this one, the factors of 8. And let me just reveal a little bit at a time here. So the factors of 8 are 1, 2, and 4 because 8 divided by 1 is 8. 8 divided by 2 is 4. 8 divided by 4 is 2. 8 divided by 8 is 1. The factors of 12 are 1, 2, 3, 4, 6, and 12. So we can see that 8 and 12 have some of the same factors, like sort of 1 is sort of it, but 2, you have 2. You have 4 in both of them, and that's it. So they have 3 factors in common. These common factors are 1, 2, and 4. So 1 is included in that. But their greatest common, that just means the largest that's the same as far as factors are concerned, is 4. The greatest common factor is often abbreviated GCF. So the GCF of 8 and 12 equals 4. Let's look at another example. Find the greatest common factor of 12 and 18. So before I reveal the solution, let me just work through that. So if I have the factors of 12, that's going to be 1 and 12. And here they're listed above, so I could use my resource. It's 1, 2, 3, 4, and 6, and 12. Those are all factors of 12. The factors of 18 are going to be 1 and 18. I'm just going to give it a little more space so I can write clear. 1, 2 times 9. I'm going to put 9 over here because it's the 2 times 9 equals 18. I'm going to move on to 3. 3 works. 3 times 6. And then that should be it. 4 doesn't work and 5 doesn't work. So those are the factors of 12 and these are the factors of 18. Now we're just looking for the greatest common factor of both of those. So you can see clearly that there would be 1 would be a common factor, 2 would be a common factor, 3 is also a common factor, 6, you can see 6 is also a common factor in both of those. And we're looking at it, the largest, which means what greatest means, same factor of both sets of factors. So you get the set of 12 factors and the 18 factors here. It looks like 6. So that's basically what the answer is. The greatest common factor, the GCF, equals 6 in this case. All right, let's look at another example. Find the greatest common factor of 6, 9, and 15. So again, just list the factors. The factors of 6 are 1, 2, 3, and 6. Those are the numbers that are divisible by into 6 without a remainder. The factors of 9 are 1, 3, and 9. Factors of 15 are 1, 3, 5, and 15. And you just look at it and you realize the greatest common factor between all three of them is 3. They all have 3 in their list of factors, and it's the greatest one at that. So the search for the greatest common factor of 2 or more numbers is a search for the largest number that evenly divides each of them. In this problem, we can quickly determine that 3 is the largest number that evenly divides 6, 9, and 15. A complete listing of the factors might be helpful, but is not required. So what is the greatest common factor of any two prime numbers? And explain your answer. So if you're thinking of a prime number, let's say 7, the factors of 7 are 1 and 7, and then I was thinking of another prime number, 5 there. That's why I accidentally wrote that. So 7, let's say another prime number, you've got 1 and 5. So you can see the greatest common factor of those prime numbers is actually 1. The GCF of any two prime numbers is going to be 1 because you've got 1 in themselves are the only things that they're divisible by. So 1 is the greatest common factor. All right, let's give a few of these a shot. Letter A, 10 and 15. What is the greatest common factor of 10 and 15? So if you list the factors of 10, I like to write it like this, 1 and 10, and then I've got 2 times 5, and then I've got 3 won't work, 4 won't work, so that's it. There's my factors of 10. My factors of 15 would be 1 and 15, and then it would be not 2, but it would be 3 times 5 is 15, and then 4 doesn't work, and that would be the end of your list. So the greatest common factor between 10 and 15 looks to be 5. So the GCF for letter A, the GCF equals 5 for letter A. Go ahead and do letter B, 18 and 27. For letter B, so if I'm going to list the factors of 18, I would want to start with 1 here. I'm going to put 18 over here so I have space to fill up the inside. I've got 2 times 9 and 3 times 6. And I know that's going to be my list. 4 and 5 don't go into 18 without a remainder. Then I need a list for 27, and it's going to start with 1 and 27. And 2 doesn't go into 27, but 3 does. 3 times 9 works. 4 does not. 5 does not. 6, 7, 8. None of those other numbers actually go into it. So looking at the greatest common one where they both have it in their list, 9 is it. So the GCF of 18 and 27 is 9. Greatest common factor. All right, do letter C, 18 and 24. All right, so I'm going to use the list I've already created to see that. I look over here, 18 is 1, 2, 3, 6, 9, and 18. And then I need 24. I've not done that list yet, so I'm going to do 1 and 24. I actually feel like this might have a big list, so I'm going to spread it out a little bit more here. 24. So I have 2 times 12. Then I'd have 3 times 8. I'd have 4 times, so for some reason my pen doesn't like to write 4s. 4 times 6, and 5 does not go into 24 without a remainder. So now I'm looking at the greatest common factor. 24 and 18, no. 12 and 9, no. 8 and 9, 6. 6 is in this list and it's in this list. So the greatest common factor of 18 and 24 is 6. All right, do letter D. It's 3 numbers this time, 12, 18, and 24. So I'm going to look at my list. I've got 18 again, using that a second time here, so I'm going to start with 12 here. 12 would be 1 and 12, and then it's 2 times 6 and 3 times 4. So those are the factors of 12. The factors of 18 I've done before 2 times now. I've got 1, 2, 3, 6, 9, and 18. And then the factors of 24 I've also done before. So I'm going to relist those. That would be 1, 2, 3, 4, 6, 8, 12, and 24. Now I just need to find what the greatest common factor is between those lists of factors that I have here. So I'm going to go to 12. That's not it. 6, 6, and right here you can see a third one. So you've got 1, 2, 3. Those look like they're all the same. It's not going to be 9 because there's no 9 in this list. There's no 9 in this list, but it's 6 and 6. So that means the greatest common factor for 12, 18, and 24 is 6. That would be your answer for that one. Do letter E, 15 and 25. So for that one, again, we need to list the factors. So I'm going to do 15, be 1, and I'm going to do 15. I can see I've done that before, so I'm just going to use that list. 1, 3, 5, and 15. The factors of 25 are 1 and 25. And then it's 2 won't go in there, 3 won't, 4 won't, 5 will, 5, but what's 5 times? 5 times 5. So look at that. That list is actually small. It's only 3 numbers. It's a bigger number, but it's a very small list. So it's pretty easy to pick out what's the greatest common one between the two there. So the GCF of 15 and 25 equals 5. Do letter F, 20, 30, and 40. All right, if you've listed the factors out, we'd start with 1 and 20, and then we work our way into the middle. This would be 2 times 10. This would be 3, no, 4, yes. 4 times 5 works, and then that'd be it. There's nothing in the middle of those. 30, the factors of 30 would be 1 and 30. It would be 2 times 15, 3 times 10, and then I would have 4 times, no, 4 won't go in there, 5 will, 5 times 6, and there's nothing in between 5 and 6 that's not a whole number, or that is a whole number. Those would be, and then let's look at 40. Be 1 and 40. Then we'd have 2 times 20 gets me to 40. 3 won't go in there, 4 will. 4 times 10. 5 won't, 6 won't, or 5 will, excuse me. 5 times 8. 6 won't, 7 won't. So that's the list for the 40s. Now I just look at my list. 20 is not in this list, so I'm going to move to 10. 10 is in this list, it's in this list, and this list. So that's the greatest one that they all have in common. 10, 10, and 10. The greatest common factor of 20, 30, and 40 is 10. All right, do letter G, 12 and 15. All right, for letter G, we've already done 12 somewhere, I recall. So I'm going to list those here if you've gotten them correct anyway. You've got 1, 2, 3, 4, 6, and 12. 1, 2, 3, 4, 6, and 12. And then you have the factors of 15, which would be 1, 3, 5, and 15. So we did that up here as well. Now I'm going to look for the greatest common one. Let's see, it's not 6, it's not 5, it's not 4, looks to be 3. 3 is the greatest common factor. The GCF of 12 and 15 is 3. Do letter H, 20, 40, and 60. So I'm going to use the 20 and the 40 just from this list. I'm just going to add 60 to this one. I'm not going to do more. I'm just going to go back to this list and review it. So I've got 1 and 60. It would be 2 and 30, because 2 times 30 is 60. 3 times 20 would be 60. Does 4 go in there? Let's see. Yes, 4 would go in there, and it looks like it'd be, what, 4 times 12 or 13? Let's see. Let me just do that real quick so I'm certain I got it right. 60 divided by 4 is 1, and then you subtract that, you get 2. Bring this down. This would be 0, so that'd be 15. So that'd be 4 times 15. Then I have 5. Feels like 5 would go in there. Let's just make sure. 60 divided by 5 would be 1. That would be 5. This would be that. Yeah, there we go. So that was the 12. 5 times 12. 6 will go in there too. I gotta put that in there. 6 and 10. 7 won't. 8 won't. 9 won't. So this list, it's a big list, but it includes all those. Let's see, do we have a 20 in all of those? No. Do we have a 30 in all of those? No. But we do have a 10. So we have 10, 10, 10, 10. See, the greatest common factor of 20, 40, 60, and 30 would actually be 10. So the answer for this one, greatest common factor, would be 10 as well. All right, letter I, write a list of 3 numbers whose greatest common factor is 7. So in order to create this list, you would have numbers that all have multiples of 7, essentially. So it might be the factors of 21, maybe. 3 numbers that have that. The factors of, you could even include the factors of 7, and let's say the factors of 28. So the factors of 21 would be 1 and 21, and then it would be 3 times 7. The factors of 7 would be 1 and 7. The factors of 28 would be 1 and 28. And then 4 and, sorry, we also have 2 in there. So we can have 2 and 14. But then it would also be 4 and 7. And if you look at the list here, the greatest common factor of those 3 numbers is 7 in all. Your list could be different. It just has to be any list of numbers that have 7 as the multiple, that are multiples of 7. So it could literally be, it'd be 7, 14, 21, 28, 35, 42, 49, and on and on and on. It could be any of those numbers. It could be any one of those 3 numbers. I just happen to choose 21, 7, and 28. So excellent job today. Go ahead and you're welcome to work ahead if you want, but it's not homework. All right, so 1 through 30 written practice, 1 through 30 is in your textbook. You can find it there. Lesson 20. It'll be unlocked at 10:45, and you'll be able to work for 50 minutes during your math class. So work on those 1 through 30 during your 50-minute math class. This is your homework. You are now finished with math homework. Excellent job.